Hey everyone, I wanted to make a quick video to cover even and odd trig functions because we didn't get to it in class. So let's first remember what an even function is and an odd function. So an even function, again, we have an algebraic definition, and that says f of negative x. If I take negative x and plug it into our function, I get exactly the same thing as if I would plug in a positive x. What this means graphically, even functions are symmetric across the y-axis. That means the left and the right sides of our graph are mirror images. And an odd function, again, if I plug negative x into my function, what I get out is the negative of my original function with a positive x value. So that's the definition of what an odd function means. And graphically, what that means, odd functions have rotational symmetry around the origin. So that means that the right side of the graph is the left side rotated 180 degrees around the origin, and the left side is the right side rotated 180 degrees around the origin. Okay, and all of our trig functions are either even or odd. We just have to figure out which ones are even and which ones are odd. And again, just looking at our functions, these don't have exponents. So I can't just look at y equals the cosine of x and look at an exponent and tell whether it's even or odd. So we're going to have to figure out how to do this. Graphically is going to be the easiest way to do this. So let's run through and define and figure out whether our functions are even or odd. And again, if it's even, it'll be symmetric across the y-axis. Our left and right sides will be mirror images. If the function is odd, then we will have rotational symmetry around the origin. So let's start all the way at the top. I have all of these graphs plugged in for you so we can kind of look at these all the way back to the beginning. And let's look at the graph of y equals the sine of x. So here's what the sine of x looks like. Is this going to be even or is this going to be odd? Well, let's start with even. Is the left side of this the mirror image of the right side? So for instance, if this is my mirror, is my left side the mirror image of the right? The answer is no. So it's not even. If I take this right side of the graph and I rotate it 180 degrees around the origin, do you see that when I rotate this around, this side, this hump here is going to rotate around and it's actually going to be right here? And this side, when I rotate it around, it's going to come and be up here. So we have rotational symmetry around the origin. Sine is an odd function. Okay, let's move to the next one, cosine. So this is the graph of the cosine of x. So we're looking to see whether this is even or odd. I think even's the easiest one to make your brain see. So let's look and see if the y-axis, if that's a mirror, is the left side a mirror image of the right side? And the answer is yes. If I take this thing and I do a reflection on the other side of my axis, it's this. They're mirror images this time, which means cosine is an even function. Cool. Let's keep going here. I've got to get through all of the transformation stuff. Okay, here's the graph of tangent. Okay, is this even? So if I look at the x-axis, sorry, the y-axis here, is my left side a mirror image of the right side? No, it's definitely not even. How about rotational symmetry? Do I have rotational symmetry about the origin? Well, let's look at this part. If I take this and rotate it 180 degrees, do you see that this would rotate down here and it would be right on top of this. If I take this thing and rotate it 180 degrees, it ends up following this, and that's going to continue on. This has rotational symmetry around the origin. Tangent is an odd function. So far, sine is odd, cosine is even, and tangent is odd. Okay, let's keep going. Cotangent. Okay, so this is our graph of cotangent. Again, let me find my y-axis here and dot that in. So if this is our axis of symmetry here, is my left side a mirror image of the right side? No, this thing does not have a mirror image on the other side, so it's not even. Is it odd? So if I take this and I rotate it 180 degrees around the origin, yes, that's going to land on top of this side. If I take this and rotate it 180 degrees around the origin, it's going to land right on top of this guy. I've got rotational symmetry. Cotangent is odd. All right, two more, and then we are through these. So cosecant. So if we look at cosecant, let's see, our y-axis is right here, if you can see that. Is my left side a mirror image of my right side? No, because here's my right side and I don't have a mirror image on the left side, so not even. Is it odd? If I take this and I rotate it 180 degrees around the origin, yes, this thing lands on top of this one. And when I take this and rotate it 180 degrees around the origin, it lands on top of this one, and it's going to keep doing that. This has rotational symmetry, which means that the cosecant function is odd. And then the last one here, this is my secant function, and my y-axis is right here. If this is my mirror, is my left side a mirror image of the right side? Yes, we have mirror images this time. The right side and the left side, mirror images. This one is mirrored on the other side right here, and that's going to continue. This guy will be mirrored over here. We have mirror images this time. Secant is even. Okay, so let's summarize this. My even trig functions, those were cosine and secant. Just those two. The rest of them were odd. So that means that the sine function, the tangent function, the cosecant function, and the cotangent functions, these were all odd. So now that we know which functions are even and which functions are odd, we can use our even and odd function definitions to help us with this. So my even functions here, I'm going to start with those. I'm going to apply my algebraic formula to my even functions. So if I take a negative angle and plug it into cosine, because cosine is even, I'm going to get the same value as the cosine of positive, the positively rotating angle. Similarly, if I take a negative angle and plug it into secant, I'm going to get exactly the same thing as I would from the positively rotating angle. And the odd functions, I'm going to apply this algebraic definition to my odd functions. So if I take a negative angle and plug it into the sine function, I'm going to get the negative of the positively rotating angle. If I plug a negatively rotating angle into tangent, I'm going to get the negative of the positively rotating angle. If I take a negative angle and plug it into cosecant, I'm going to get the negative of the positively rotating angle. And if I put a negative angle into cotangent, I'm going to get the negative of the positively rotating angle. So eventually we are going to call these identities. These are even and odd trigonometric identities. For now, we're just going to apply those to some functions. So let's look at number one here. It wants us to write an equivalent expression using even and odd functions. So I want to know if I take the cotangent of negative 85 degrees, I just want an equivalent expression um, with a positive angle in here, basically. So if I take a negative angle and plug it into cotangent, let's see, I'm going to come here to the cotangent formula. If I take a negative angle and plug it into cotangent, what I'm going to get out is the negative of the same positively rotating angle. So that means this is going to be the negative of the cotangent of positive 85 degrees. It doesn't want, Alex is not going to want you to evaluate this and put it in a calculator. It literally just wants you to apply the identity and write that expression. And that's the end of this problem. So let's try number two. We have the cosine of negative 2 pi over 5. We're going to come up here to the cosine identity, and the cosine of negative 2 pi over 5. Because cosine is even, I'm going to get exactly the same thing as I would if I took the cosine of positive 2 pi over 5. Um, you'll get the same thing as with the negative angle as you do with the positive angle. And so this is your equivalent expression using even and odd functions here. So you'll basically just apply these even and odd identities to the expressions that you're given. Again, don't evaluate those in a calculator, just write an equivalent expression and you're good. All right, that is the end of homework 6. That homework is due on Sunday at midnight, and don't forget you have a test on Monday, and your um, test 2 study guide is due on Monday at test time. Have a great weekend. Let me know if you have any questions, and I'll see you on Monday for the test.